Venus is the sixth largest planet in the solar system. At its closest, it is 26 million miles away from Earth. A year on Venus lasts 225 Earth days. And if you weighed 150 pounds on Earth, you'd weigh 136 on Venus. Venus. When the ancient Romans looked up, they were captivated by its commanding presence. They named the planet after their serene goddess of love and beauty.
It's such a beautiful presence in the sky. It seems obvious the connection there.
Venus has long been considered our sister planet because of its closeness in composition, gravity, density, and size.
Venus and Earth are almost twins in a lot of ways. They're almost the same size. Venus is slightly smaller than Earth. So if Earth was a regulation basketball, Venus is a soccer ball, slightly smaller. And Venus is the closest planet to Earth. So for a long time, it was thought of literally as a twin planet.
For ages, scientists thought this twin, like Earth, was a planet covered with deep oceans, lush rainforests, and had a climate that would give credibility to the notion that intelligent life could exist there.
Before the space age, people thought it might be very Earth-like on Venus. But the paradox is when we actually got to Venus and started exploring it, the conditions there are so different.
It turned out Venus was less of an exotic sister to Earth and more of an evil twin.
So here you have two very similar planets in their sort of bulk properties, but they've evolved to such different states. And that creates an interesting problem in understanding planetary evolution, a sort of controlled experiment. Take these two similar planets and let them go for 4 billion years, and then why do they end up so different?
First, some of the basic differences. Venus has been hit hard with meteors. One so strong that some scientists think it may have reversed the planet's rotation.
Venus has a very slow rotation, and it has what we call a retrograde rotation. So it spins backwards compared to the direction of spin of all the other planets.
Because of this retrograde rotation, the sun rises in the west and sets in the east. And the Venusian days are long ones. The amount of time from one sunrise to the next is about 8 Earth months. But the orbital pattern and long days aren't what make Venus so intolerable. In part, it's the wicked climate. With a surface temperature of 900 degrees Fahrenheit, Venus is the hottest planet in the solar system. Travelers there would have their trip cut short in no time.
It would take a matter of seconds, maybe 1 second before they were gone, roasted to death.
If you're an astronaut sitting on Venus without a spacesuit, then your skin's going to crisp up. You're going to cook just like a turkey in an oven, except much faster even.
The unforgiving heat wave is created by a process called the greenhouse effect, the identical process that keeps Earth's climate in check and teeming with life. But a closer look at Venus tells us how this common trait can be a cycle of life and a cycle of death. Today, our own temperature is on the rise, and scientists found the possible cause behind it up on Venus.
Global warming is a result of greenhouse gases that are growing and growing and growing, and therefore we're getting hotter and hotter. When we looked at Venus, we said, aha, here it is actually happening.
In the 1990s, after the Magellan spacecraft was launched, planetary watchdogs began turning to Venus to surmise just how bad it could get here on Earth.
Space exploration has told us a lot about the Earth and the environment it's in. And in fact, the greenhouse effect that everybody's talking about with global warming was actually discovered on Venus.
What they found out about Venus shed new light on how fragile Earth's greenhouse effect really is.
Venus didn't always used to be this hot. We think that early in its history it was more Earth-like on the surface, and it lost its oceans due to what we call a runaway greenhouse effect. So Venus is an example that certainly that global change can happen on a planet, and it's sort of a worst-case scenario. We don't have to turn Earth into Venus before we're in trouble. We just have to move a little bit in that direction. And we are moving in that direction. But the real value of studying Venus, it allows us to test our climate models.
Through computerized general circulation models, or GCMs, scientists were able to calculate temperature increases on Earth based on the amount of greenhouse gases on Venus. So just how does Venus's greenhouse effect work and make the planet so hot? This is Biosphere 2. Located along the foothills of Arizona's Santa Catalina Mountains, it was built by a group of researchers to explore the idea of colonizing other planets. It is the largest greenhouse on Earth.
Biosphere is a perfect example of a greenhouse because it's a big building with glass panes that let the sun in, and the air is really hot in here.
The solar rays that penetrate the glass panes cause the temperature inside to rise.
The air heats up, but then the air cannot escape, cannot move vertically into the atmosphere because of the walls.
The windows trap the heat, warm the building, and provide the plants and trees with a livable climate. On Venus, greenhouse gases don't exactly trap the sun's heat, but they greatly slow the rate at which it can escape.
The greenhouse effect on any planet is a situation where the surface temperature becomes hotter because of gases in the atmosphere that trap the heat while letting in the sunlight.
These same greenhouse gases that would prove to be fatal to us on Venus are essential to life on Earth.
Without the greenhouse effect, the average temperature would be far below freezing, the oceans would be totally or almost totally frozen, and it's not even clear if life would exist on the Earth.
We talked about how hot it was, but why is it so hot? The answer has to do with the atmospheric composition. It's almost all carbon dioxide there.
Carbon dioxide, or CO2, makes up 95% of the Venusian atmosphere. And that high volume of gas traps more heat.
That's going to give you a strong greenhouse effect, and that's going to make it really hot. And that's why it's so hot on Venus. It's an extreme example of global warming.
On Venus, volcanoes are the natural spring source for CO2 and other gases. It's a process atmospheric chemist Jeff Sutton studies on Earth at Hawaii's Kilauea volcano. Deep below the surface, atomic compounds ignite during volcanic activity to form CO2. The gas is born from the pressure created by the heat of molten rock, or magma.
It rises towards the surface and reaches the summit magma storage complex. The pressure is decreased on the magma. And the effect of that is to allow gases that are trapped under the very high pressure to be released and bubble out.
The Venusian surface would likely have cracks in the lava similar to these vents, where gases escape into the airstream.
Somewhere between 8,000 and 30,000 metric tons of carbon dioxide boil out of the magma chamber each day. And it amounts to something on the order of 3.5 to 5 million tons per year.
And that's just one volcano here on Earth. Venus has more active volcanoes, and that means more heat-bouncing gases.
So all the CO2 just builds up in the atmosphere on Venus, which just makes it hotter and hotter.
The 900-degree heat isn't the only trait that makes Earth's twin seem a menace. 30 miles above the scorching ground of Venus, there's havoc occurring on the planet that makes 900 degrees Fahrenheit feel like a cold front. Electrical mayhem, where split-second jolts can reach 50,000 degrees. Each spark of light contains 100 million volts of electricity.